everybody and welcome to this video on exponents. In this video, we're having a look at more exercises. All of these examples have addition or subtraction, so we will go through the correct way to simplify these further. Please note that with addition and subtraction, we can't just do anything willy-nilly. We have to factorize and then simplify. So we're going to be using that concept of factorization to simplify these questions. Please pause the video and attempt the questions by yourself before doing them right now. Okay, so let's start at the first one. We have 3 squared plus 3 to the power of 4. So the trick here is to factorize. What's common between the first term and the second term is 3 to the power of 2. So we take it out as a common factor, and 3 squared divided by 3 squared is 3, and 3 to the power of 4 divided by 3 squared is 3 to the power of 2. This we can then simplify to 9 times 1 plus 9, and that is then 9 times 10, which is simply 90. Okay. Let's have a look at the second one. We've got 2 to the power of x plus 1 plus 2 to the power of x. Now, what's common between the first term and second term is a 2 to the power of x. So what we're going to do is take it out as a common factor. So factorizing 2 to the power of x out, and 2 to the power of x divided by 2 to the power of x. And when you divide, you remember that to subtract the exponents. So it'll be x plus 1 minus x, leaving us just with 2 to the power of 1, and 2 to the power of x divided by 2 to the power of x is 1. So this simplifies to 2 to the power of x times 3. If you want to, you can write it as 3 times 2 to the power of x, and that's as simplified as it gets. Let's have a look at the next one. Once again, we want to take out the highest common factor. So what is common between 3 to the power of 2x and 3 to the power of 2x plus 1 is a 3 to the power of 2x. So we're going to take that out as a common factor. And what are we going to be left with? 3 to the power of 2x divided by 3 to the power of 2x is 1. And minus 3 to the power of 2x plus 1 divided by 3 to the power of 2x is minus 3 to the power of x plus 1. So this here is 3 to the power of 2x times minus 2, which you can just write as minus 2 times 3 to the power of 2x. Okay, let us have a look at the fourth one. What is common between these terms is 2 to the power of m, so we're going to take it out. And what are we going to be left with? 2 to the power of 1 plus 2 to the power of 2. So this here is 2m, 2 plus 4, which is just 6 to the power, times 2 to the power of 2m. Okay, let's have a look at this one. Now, what is common? Over here, they both have in common a 2 and a 5 to the power of x. So dividing this side, we get a 1. Plus, here if we divide 2 to the power of 5x minus 1 divided by 2 to the power of 5x, we get 5 to the minus 1. And remembering from your exponential laws, you can write this as 1 over 1 plus 1 over 5, which you can then simplify as 6 over 5. And I guess you can then just write this as 12 times 5x over 5, which I guess you can write as 12 times 5x minus 1 if you wanted. Okay, anyway, that's just simplification, but you get the concept that we first divide by what is common. Okay, so number 6, what is common between these two? So the 2 and the 4 have a 2 in common, and then there's also 3 to the power of x, so we'll take that out. Then what we have is a 1 over here. Very often when you're dividing the same thing, you forget to put a term there. Remember, the same thing divided by itself is 1, and then here 4 divided by 2 is 2, and 3 to the power of x plus 1 divided by 3 to the power of x is just 3 to the power of 1. This is 3 to the power of 2x times 1 minus 6 which is minus 10 times 2 to the power, times 3 to the power of x, if we simplify that further. Okay, let me do number 7 here at the bottom because the space there is not enough. So we have 3 to the power of n plus 4 minus 6 to the power of 3n plus 2. So again, we want to factorize. The numerator has 3. Okay, so I'm going to first convert the 6 to prime bases. So this is 3 to the power of n plus 4. And instead of 6, I'm going to write 2 times 3. Okay, so that's what 6 is in prime braces. And then we have 3n plus 2. And then I want to simplify that by grouping the 3's on this side. So this here becomes 2 times 3 to the power of n plus 3. So that n to the power of 1, I just added it over there, and we have n plus 3. So now we can see that there's a 3 to the power of n plus 3 in common. And when we divide that over there, we're going to have 1 3 here and a 2 over there. So this here is just 3 to the power of n plus 3. Okay. Let's do number 8 over here as well. So we have 8 to the power times 5 to the power of m minus 1 plus 2 to the power, times 5 to the power of m plus 1. What do these two have in common? Well, there's a 2 and a 5 to the power of m because 8 goes into 2. So then this here gives us 4 times 5 to the power of minus 1. And then this one here, the 2 goes away, and then we just have plus 5 to the power of 1. So then simplifying this further, we have 4 over 5, because the 5 goes into the denominator, plus 5, which you can then simplify. So this is 2 to the power of 5m times, if we put it over a common denominator of 5, we have 29 over 5, which I guess you could simplify into 38 times 5m minus 1. Okay. Let us look at number 9. Now, number 9, it's very tempting. You want to cancel these two m's out, but please remember that you cannot cancel over plus or minus. So what we're going to have to do is factorize. So we're going to take out m cubed, and what we're going to have is 1 plus m in the numerator over m cubed. And now that the operation between these terms is multiplication, we can cancel, and that's just equal to 1 plus m. Similarly, you can't cancel this 2x with the 2x. I know you really want to, but we have to factorize. So we take 2x out as a common factor between the two terms in the numerator, and we get 1 plus 2 to the power of 1 over 2 to the power of x. Then we can cancel, and that finally gives us the 1 plus 2. Okay, I hope you've understood the concept of this video. Please do watch it again and watch the previous ones if anything was confusing, and make sure that you understand it, because it's very important concepts. Please watch our next video on exponents with more trickier examples.